Okay, no more rules, I promise. We're done with the rules. So I'd like to start by looking at one of these functions, 1, 2, 3, or 4. And I know it's a long problem, but it's extremely important type of problem. We're going to see the discussion that we're going to have here. Nothing is difficult in this problem. There is one little thing that we have to discuss. The rest is just pretty straightforward. So let's say a particle moves according to a law of motion. Okay, so f of t, and of course t is time, has to be greater than or equal to 0. So t is measured in seconds and s in feet. So let's look at problem 1. We can choose another in a minute. So f of t equals t cubed minus 9t squared plus 24t. Okay, so let's start from the top. I have to mention here that f is measured in feet, or s is measured in feet, and t in seconds. So I don't forget. I will not, but we should always do that. Find the velocity at time t. So this is our s of t, or f of t, same thing. Distance of time. How do I find, part A, how do I find the velocity? Velocity. How do I find the velocity?
We differentiate.
Exactly. So this is exactly s prime of t. The rate of change of distance with respect to time is velocity. Can anyone differentiate this simple function for us?
3t squared minus 18t plus 24.
This is it. This is the velocity, and this is done. Nothing new so far. Let's take a look at part B. What is the velocity after 1 second? Okay, what am I asked to do now? How do I determine the velocity after 1 second?
You just plug in 1 for t.
Perfect. So I have 3 minus 18 plus 24. So 24 minus 18 is 6. 6 plus 3 is 9. I have to write the measurement unit. Remember, v is a derivative. It has to have 2 measurement units. One coming from the top and one coming from the bottom. So what is the measurement unit for 9?
Would that be feet per second?
Absolutely. So feet, the variable y is at the top, the variable x is at the bottom. Nothing new so far. Moving on. Part C. When is the particle at rest? At rest. What does that mean?
When velocity goes 0.
Yes. When velocity is 0, absolutely. Okay, I have the velocity here. 3t squared minus 18t plus 24 equals 0. You have the option of using the polynomial feature in the graphing calculator and determine the solutions. If you have difficulties factoring, or if it takes too long, use the feature in the graphing calculator. Of course, you know me, I will simplify as much as I can. So I get t squared minus 6t and plus 8, because this is very easy to factor into t minus 2 and t minus 4. And I get t equals 2 seconds and t equals 4 seconds. So this particle does whatever it does, left, right, whatever, but at second 2 and at second 4, the velocity is 0, so the particle does not move at those points, at those t values. Okay, this was part C. Part D. D. When is the particle moving in the positive direction? Okay, so again, the particle starts somewhere and does this. When the particle moves in this direction, we say it's positive, in the positive direction. In this case, the particle moves in the negative direction. It comes back. In order to determine that, we have to study the sign. So this is my part, what was it? Of course, it's D. Very important. Study the sign of the derivative that's the derivative, the velocity. So I'm going to do this. T from 0 to, not possible, but you know what I mean. I'm going to put here v of t. I know I'm anticipating, don't even look at this one, but please have enough room, don't write it if you don't want to, but have enough room under your velocity for the acceleration. We're going to come back to it, and also allow one more row. So we have not discussed these two, but please allow some room and we'll come back to those. I already know that at 2 and 4, we identify the fact, or we know that at time 2 seconds and time 4 seconds, the velocity is 0. I go back to the velocity formula. This is the velocity formula. I want to determine the sign here between 0 and 2. I want to determine the sign here between 2 and 4. And I want to determine the sign here above 4. I'll plug in 0. Can anyone plug the t, replace t by 0, and don't calculate anything? I only want the sign. I don't care about the number. I want you to tell me the sign, and I will put it in.
That'd be awesome.
Now we want to plug in 1. 1. Can anyone plug in 1? I don't need the number. I only need the sign.
Do you mean 3?
So when we plug in 1.
Positive.
So hold on one second. So this was velocity. So that was positive. Oh, no, not 1. I'm sorry. 3, of course. Doesn't mean 1 is here. Sorry. 3. Sorry. Just perform the calculations between 2 and 3, between 2 and 4, 3. I don't even want to put in the table. It's not important. I just need the sign here.
That'd be negative.
Perfect. And let's say we plug in 10. I don't need any number. I just need the sign here.
I'm getting positive.
Absolutely. So, when is the particle moving in the positive direction?
When it's less than 2 or greater than 4.
On 0, 2, union 4, infinity. When is moving in the negative direction?
Between 2 and 4.
Between 2 and 4. Excellent. E. So where is E? Find the total distance traveled during the first 6 seconds. What is the part? So we answered 2 questions here. We have to. They're only asking for positive, but we want to determine both. Find the total distance traveled during the first 6 seconds. Perfect. Total distance on 0 to 6. So let's analyze what happens here. First of all, between second 0 and second 2, it's going in the positive direction. Between second 2 and second 4, 2 more, it's going in the negative direction. Between 4 and 6 is again going in a positive direction. So in order to determine the total distance, I have to write the absolute value of s of 2 minus s of 0 plus the absolute value of s of 4 minus s of 2 plus the absolute value of s of 6 minus s of 4. You can say, you don't need the absolute value on this. You don't need the absolute value on this. Because obviously the distance here minus the distance here will be positive. The distance here minus the distance from here will be positive. You only need the absolute value between these two because the velocity is negative. The particle is coming back. True, but we have to write it as is. All I need to do next is in S of t, plugging all these numbers, 0, 2, 4, and 6, and calculate these absolute values. And that will be the total distance covered by the particle. Going this way 2 seconds, coming back 2 seconds, going back 2 seconds. So you know me, I'm going to put in the graphing calculator, I'm going to put S of t in y equals, clear whatever you have. So S of t, 3 pages ago, I know it's a long problem. S of t is t cubed, and then minus 9t squared, and then plus 24t, and then I go to second and table. I know the 0, you don't have to plug in 0, of course. I have 2, 4, and 6. 2, 4, and 6. Perfect. And now I will copy these numbers. What am I copying? So I'm going to write again. That's my page 9. Total distance equals s of 2 minus s of 0. So 20 minus 0 plus s of 4. 16 minus 36. And then plus s of 4 minus s of 2. Sorry, minus 20. Then s of 6 minus s of 4. So s of 6 is 36 minus s of 4, which is 16. So then s of 2 minus s of 0, s of 4 minus s of 2, s of 6 minus s of 4. This will give us a total distance. Of course, this is positive. It didn't need the absolute value. Of course, this is positive. It's also 20 by it happens. So it didn't need the absolute value, but this one does. 16 minus 20 is negative 4. The distance has to be positive. If I go to school or I come back, the odometer will not subtract. Will still add, right? So this has to be added, this has to be added, this has to be added. So then plus 16 minus 20 is negative 4, and absolute value is 4, plus another 20 from here is 44. And this has to be feet. It's the total distance, is not a derivative. That's how we determine the total distance. Any questions so far? Okay. That was E. F, we already did. G, find the acceleration at time t and after 1 second. So in G, the acceleration and then the acceleration at 1. How do I determine the acceleration? So as I said several pages ago, we have the velocity. So I'm going to copy the velocity here so I can put these away. 3t squared minus 18t plus 24. How do we determine the acceleration?
We differentiate the velocity.
We differentiate the velocity. So v prime of t equals a of t, which is also the second derivative of distance. When we differentiate the distance the second time, or we differentiate the velocity the first time, we get the acceleration. Can anyone differentiate this so I can put the acceleration up here?
That'd be 6t minus 18.
That's it. Indeed, 6t minus 18. Perfect. And we're asked to find the acceleration at 1.
Negative 12.
Negative 12. Measurement unit now. Careful. That s of t is measured in feet. V of t is measured in, not meters, feet per second. What is the measurement unit, which cannot be the same with this? It cannot. What is the measurement unit for acceleration?
Feet per second squared.
Yes, excellent. So please understand, these are 3 different concepts. They cannot have the same measurement unit. Feet per second squared. This is the rate of velocity, the rate of change of velocity with respect to time. Velocity over time is feet per second squared. Awesome. So this is feet per second squared. Perfect. Okay. Now, you can say a negative acceleration. Yes, it's possible because the velocity is decreasing. Okay, so now let's see what else they want. Graph with a graphing calculator, we can do that. There is no problem. But I'm more interested in I. When is the particle speeding up? When is it slowing down? Okay, so I need to explain something first of all. Let's suppose we are on a bike ride. So we go this way, and let's say I can do only, I don't know, 10 miles per hour. And I have a tailwind, a backwind of 2 miles per hour. What is my speed now? So I go in this direction, let's say 10 miles per hour, which is probably for me huge. Anyway, I don't know. So, but I have a tailwind or backwind. So what is my actual speed?
Uh, 12.
Yes, 12 miles per hour. Now I'm going in this direction again with 10 miles per hour, but this time I have a headwind of 3 miles per hour. What is my actual speed?
Seven.
7. Yes. So when we talk about this, about I, in our problem, speeding up or slowing down has to do with 2 forces either helping one another, which means speeding up, or 2 forces that are against each other, which means slowing down. So we speed up when we are on a plane that has a tailwind, so the velocity will be higher than what the plane can do or wants the pilot to do. And here, if we are on this plane and it has a tailwind, it will take us longer to get to our destination. Why? Because the speed is smaller than what we can really do without this in front of us. So therefore, we're going to go back where I created that table. And now the table is only asking us between, or the question is only asking us to discuss what happens between 0 and 6. We're not going to go to infinity. So between 0 and 6, I know exactly what the velocity does, but I don't know what the acceleration does. So I go back to the acceleration. The acceleration a of t is 6t minus 18. Can anyone tell us when is a of t 0? In other words, when 6t minus 18 is 0? And I know you will say when 6t equals 18, when t equals 3 seconds. Awesome. So then I know. Now I have no choice and put 3 in there. And I know the acceleration is 0 at 3 seconds. I need the sign before 3 and the sign after 3. So in this expression, plug in any number between 0 and 3. The easiest will be 0. When you plug in 0, what is the sign? I don't need any number. I only need the sign.
That would be negative.
Negative. And then plug in 10 and just tell me the sign and I'll write it here.
Positive.
Yes, indeed. So as you see, we have created several sub-intervals. This is one. This is the other. This is another one. And this is the last one. 1, 2, 3, 4. And now here's our conclusion. When the velocity is positive and the acceleration is negative, what does the particle do between 0 and 2?
Slowing down.
Between 2 and 3, the velocity goes this way, the acceleration goes this way. What does the particle do between 2 and 3?
Speeding up. Mhm.
Between 3 and 4, the velocity is going this way, the acceleration is going this way. What is the particle doing between 3 and 4?
Slowing down.
Finally, the acceleration is that way and the velocity is this way. What is the particle doing between 4 and 6?
Speeding up.
That's it.